This is just a little refresher on how to simplify radicals, things that have square root in them. So thinking about, let's just think about some things that we know. For example, square root of 25, we know that that's 5 because 5 squared is 25. Let me think about a different one. What if I had the square root of 144? Like, you might know right away that that's 12, that the square root of that is 12. But you might not see it right away. So what you can start to do is break it up into pieces. Square root of 144. Let me think about 144 for a second. 144. That's I know that 4 goes into that because I got that 44 at the end. So let's see, what could that be? That could be 4 goes into 14 36 times. And now notice, like, I know the square root of 4 and I know the square root of 36. So now I can think of this as the square root of 4 times the square root of 36. Now square root of 4 is 2, square root of 36 is 6. 2 times 6 is 12. So notice that as I'm doing square root, I can do it all in one jump if I know it. Or I can do it in these pieces. I break it up into factors, things that multiply to that value. So, that being said, let's say I had something like the square root of 75. I'm not going to be able to jump, maybe I could use my calculator, but I'm not going to be able to jump straight to some answer for square root of 75. And even if I use my calculator, I'm going to get some decimal that goes on forever, repeats itself forever. I'm sorry, does not repeat itself forever, it just goes on forever. So square root of 75, what I want to do is as much of the square rooting as I can to get whole numbers, and then whatever is left over is an irrational piece. I'm just going to leave it under the square root. So notice I broke up 144 into 4 times 36. I'm going to try and break this up into some pieces, and it's going to be really advantageous to me if those pieces happen to be perfect squares. So 75, I know there's a 25 that goes into that. 75 is 25 times 3. And notice the whole thing's being square rooted. And that's the same as the square root of 25 times the square root of 3. And I know the square root of 25 is 5. And 3, I'm not going to get any other perfect squares out of that. 5 root 3. These are equivalent. They're the same value. In other words, if I put them both in the calculator, I'm going to get the same decimal expansion. But this is simplified because I've done as much of the square rooting as I can. Let me think about and maybe try one more example. Clean this up just a little bit. Boy, it looks messy. So again, the idea with simplifying radicals is to do as much of the square rooting as I possibly can. So one more example. Let's say I had the square root of 700. So 700, 100 goes into that. So that would be the same as square root of 100 times 7. Let's see, square root of 100 is 10. So 10. And notice 10 is no longer under the square root because it's been square rooted. 100 square rooted is equal to 10. The square root is spent, but it's still 10 root 7. Let me try another one, square root of 800. Now, sometimes you don't necessarily see the big square all the way right at the start. So square root of 800, I'm just going to say, all right, that's square root of 100 times 8. Just because that's easy, I know the 100. So square root of 100 is 10. So that leaves me with 10 square root of 8. And now from here, I need to check and make sure that I'm done. If I look at this part that's square rooted, if there are any squares I can pull out of that, again, this kind of remainder part, I'm going to take them out as well. So I might not get the biggest square in one big jump, but I know that, I'm going to write down here, 8 is 4 times 2. And square root of 4 is 2. So now I have 10 times square root of 4 is 2 times this 2 is being square rooted, square root of 2. And 10 times 2 is 20. So that wraps me up with 20 square root of 2. And that tells me I could have been a little more efficient. I could have split 800 into 400 times 2. Square root of 400 is 20. But it doesn't matter. Even if I do it a piece at a time, I can still get it down to doing as much of the squaring as I can, and then whatever's remainder is still being square rooted.